something that we talked about earlier in the right at the onset of the episode, and that would have come up, I'm sure, as you were developing the product in that kind of Word document, is this reproducibility issue. So the Jupyter Notebook has been a very standard tool for a decade now for data scientists, but you've cited a study previously showing that only 4% of Jupyter Notebooks reproduce their original results due to issues that you called a hidden state trap, among other kinds of problems. Do you want to dig into these kinds of problems with reproducibility that Jupyter Notebooks have and how Marimo resolves them?
Definitely. So just to caveat this discussion, I think like every notebook does have its place, and like with Jupyter notebooks, I think they are well suited to like REPL like workflows where maybe you're not shooting for reproducibility, but you're like quickly really hacking things. The issue is though, then I think like because it's such a great environment for interactive coding, people started using them and really relying on them for issues where for use cases where reproducibility is paramount, like data engineering, like science, like machine learning. And so the question was dig into some of those reproducibility issues, right? And how Marimo solves them. So two main classes. So one is the issue of hidden state, where in a Jupyter notebook, you run a cell. Jupyter's not going to run the cells that depend on it, like the cells that use its variables. And it's up to you to remember all the complicated dependencies that might flow through your notebook. And you're going to forget some. I often did, right? And so now your notebook is in some weird, inconsistent state. So that's one issue. To make that like really like pronounced, I guess is like so in a traditional notebook like Jupyter, you can like say like you have a cell that like I don't know, it's got a bunch of code in it, and maybe one thing that cell does is like create some like PyTorch model class, like instantiate some class, and then say you delete that cell, um, and then you continue coding elsewhere in the notebook. You deleted that cell, but say you didn't realize that that was the cell that defined the model class, and you really wanted that model class around. But in Jupyter, if you delete that cell, that model is still in memory for the time being, and so your rest of your notebook will work as you want it to work. But you come back the next day and you run the notebook from scratch, nothing works, and you're like, "What happened?" And it's like, "Oh crap! I deleted the cell that defined the model, and like I really needed that." So in Marimo, if you do that, if you delete the cell that defines your model variable, it'll tell you and it'll remove the model from memory and like it'll invalidate the other cells. You'd be like, yo, that variable is no longer around, like you can't do this anymore. And so it'll catch bugs like immediately when you introduce them. So that's one big way. And the second big way is package management. And so Marima has a special sort of, I guess, opt-in package manager, which I think is really neat. So basically, if you start Marimo in a mode that we call sandbox from the command line or however, um, every time you install a package, Marimo has a very nice, slick package installation UI. We will save the package that you installed and the version as like a comment or an entry in the notebook file itself. And now when you come back to the notebook a second time and try to run it, and you do run it, Marimo will create an isolated virtual environment for you that has just those packages. So that means that like you can just send a single notebook file around and like people can just run it without even thinking about what packages they need to install, which makes them more reproducible, but also they're just like a lot more portable. It's like really easy to just create these single standalone tools and share them.